Okay, our next speaker up is Mr. Michael Glover. We are going to continue exploring brain plasticity related to stroke with Michael, and he is the Vice President of Clinical Operations at Exobionics, which is a global leader in wearable robotic technology that is redefining recovery after stroke and neurological injury. If you listen to Stacy Barber's presentation, she and Logan used one of those robotic gloves to help their process. So Michael's going to help us understand that in more detail. They don't only have gloves, they also look at complete robotic exoskeletons, which are used in some of the leading neurorehabilitation centers worldwide to help patients relearn how to step, stand, and walk and use all of their limbs that have gone into non-use. So Mike really works at the intersection himself personally of advancing engineering and hands-on clinical care because he's bridging that gap between the teams who build Exos technology and the therapists who use it every day. So he's going to be able to help us not only understand the theory of this, but also the application of it. Mike is going to share how these robotics are harnessing neuroplasticity in a lot of different ways and why repetition is essential for brain healing. We're going to dig into that a little bit and how this technology is really shaping the future of neurological recovery. So welcome, Michael. I'm glad you're here.
Thanks, Sherry. Really happy to be here. Thanks so much for having me.
Yeah, yeah. So we've already heard some of your work referenced in one of our sessions today, and I think it came up in discussion yesterday as well. I would love for you to kind of help get us all grounded on what these exoskeletons are, how what you're doing at Exo works, and how it can support a stroke survivor's progress. So I know you've got some slides. Why don't you go ahead and take the floor and walk through those for us?
Great. Thanks so much. Hello, everybody. Thanks so much for having me today. Looking forward to sharing some about the wearable robots that Exobionics is creating to support stroke health and recovery. Okay, so on this first slide, there's an image here of somebody who had a stroke and recovering, walking in the exoskeleton to give you a visualization of exactly what the robot is. So ExoNR is a wearable robot that is battery powered with motors at the hips and the knees. What this does is it provides the individual the opportunity to stand and walk over ground in a full weight bearing state. They also have the opportunity to navigate the environment, which is really important for that neuroplasticity and that brain recovery. Um, the other important thing for ExoNR and these wearable robots, exoskeletons, is they're adaptable. So for individuals who lose function to one or maybe both legs or one full side of their body, the device will respond to what their function capability is. And so it can provide as much or as little power as necessary to help them stand and ultimately take as many steps over ground as they can tolerate. So if you're thinking about some of how you started covering some of the recovery of a stroke from the stroke, those early days you may be doing as little as just standing and not taking any steps at all. And what this device will do is will provide you that opportunity to help stand and take not only just few 10 steps, but hundreds and maybe up to 1,000 steps, and really starting to look at that repetition that we all know is so vital for neuroplasticity. So why are we doing this with the overground exoskeletons? It's because we want the person who's in the device to be an active participant. The person is actively engaging with the robot and the robot responds. So it's adapting to what the person's able to do. If they're falling behind and that person needs the support, the XO will provide that support. But if it recognizes the person's doing the work, then it backs off to allow that person to continue their arc of recovery. What this does is it helps them functionally engage with the robot and the environment to help with that top-down approach to let that brain start healing and that progression of function. So why are we doing all of this? That's why you're all here today. It's specifically for neuroplastic results. So when we're thinking neuroplastic results, we're thinking increased dosage and increased intensity, high repetition, task specific or task oriented exercise. And then we want to think about that top down and bottom up approach when you're not only thinking of what you want to do, from your personal recovery, but also what that therapist is helping support. What we want to do with this is just think about how the brain functions. And I just put up an image here from a study that was designed around how people's functional recovery happens over what we consider overground gait training and exoskeleton type gait training. And the image on the left side of that screen with all the black lines is showing how all the different tracts of the brain communicate with each other. On the top, when you see these bright red lines, the people that were working in the study in an exoskeleton were having a lot more brain function, as you can see all the different tracks connecting more so than those in the lower group. So this is giving you that opportunity, like I said, to stand and walk and take hundreds of steps, and these really good functional steps that are creating that nice stepping pattern and helping to reduce any compensatory strategies that our body tends to pull in so we can continue to functionally walk. And what I want to do is just bring you through one example of someone who had a traumatic injury but then also had a stroke. And so if you look at these images, this is something that might seem and look familiar to some things that you've seen before, or maybe even personally went through. So the first image is this person, she was in the bed because she was unable to really engage at all. And one of the things that, in the rehab terms, is we call it a locked-in syndrome, where she wasn't really able to engage with the environment. So the therapists were trying a whole lot of different things with her, including a standing frame, walking in parallel bars, and then some body weight support harness-based systems where you basically have the support of an overhead tethered harness. And they weren't finding they were getting exactly what they were looking for with the functional recovery. So then they decided to try to use the exo system. And so the first video that I'm going to play here on that left side of the screen. So she's still not fully able to really engage with the environment, but they decided to try her in the Exo NR. The first stand you'll see. Let's see the video will play.
Whoa. How cool
Okay,
is
so
that?
they first get her up to
That
standing,
is crazy.
and the way the device can function for someone like her is that they can put it in such a mode that once she gets her functional balance point, so she shifts her weight, she gets balanced on that standing leg, the trailing limb will take a step. And so what they were trying to do here, what they successfully were able to do was to get internal, to like kind of tap into that intrinsic learning system where she could just start feeling what that walking pattern really is and how to tap back into those all those little neuros that she knew like how to get back to that functional gait. So then with the last video showing just how successful she really was and her full arc of recovery and functional gains. She's now walking without the support of the exoskeleton system at all and just using the rollator walker. And that really is just a testament to a true success of how you can have such a really strong arc of recovery from very little function to none at all, and see how this device can help grow with the individual as they get better. And then ultimately, the final goal is to walk out of the system. Okay, let's see. And so that concludes some of the overview I wanted to share. And so, Sherry, I think we're going to go back to some questions.
Yeah. For sure, Michael. Thank you so much for that. I think that gives us a good idea of what it does and what it's capable of doing, and how remarkable that shift can be from using it. I wanted to just ask on a personal note. So, Michael, your background is of the engineering side, and then you've come into the bionics piece. Was there a personal why that led you down to this career path?
Absolutely. So I do work at Exobiotics with a lot of engineers, but I am personally a physical therapist.
Okay.
Um, and how I first got into physical therapy is a very personal story, actually. When I was in high school, my grandmother actually was diagnosed with brain cancer. and had a tumor that was resected, but ultimately presented like someone who had a stroke because this is back in the 90s and she had a pretty aggressive surgery. And I watched her go through her recovery. And I was always so fascinated by seeing her go through the having the therapist come into the home. And I was her young cheerleader, I would say, that tried to help her motivate some to want to get out of that hospital bed that was in her bedroom and try to get up and stand and motivate into that recovery process. So I learned about this at a very young age and inspired me to go into the profession.
Yeah, and that story of personal triumph and a personal appeal, it does resonate with almost every single person who is making significant advances in this space. There seems to always be a personal why.
Mhm.
So we're glad you were able to help your grandmother through that and then learn how to apply that to help so many other people. So I'm wondering, like, when that video and I was looking at that and that person who's learning to walk, little to no movement, right? All the way to just being able to use a rollator and not having to have any real mechanical support.
Mhm.
What is the aha moment in their brain, or what happened? What's the trigger that enables them to move from the mechanics to their own support, their own biology?
I think what it shows the individual in the device is that they can see real results. So the device itself demonstrates to the individual how much assistance it's providing them. So that it'll provide them on a scale of 0 to 100, basically. And so we grade it pretty easily, like most of us understand scoring. And they can see, oh, wow, I'm actually doing most of the work here. And it also demonstrates that they've taken hundreds or thousands of steps with that supportive environment. And then sometimes that aha moment is when we say, okay, now we're going to take this off of you. And I want you to try to stand again. And I want you to recreate what we just did, what we did, how we just trained within the system. Now we're going to remove that and see, and can you carry over what we just taught you? And those aha moments are the not only for the user, the person that's in the device, but also the clinician because the
Mhm.
clinician when they first see that first person that they help in the device and they see even from a single session they go from very little function and very few steps to at like a 10x or 20x of number of steps in the functional ability. It really helps them to understand how and why these products help support recovery.
And is that support that the machine is giving a gradual decrease over time? So you said it's responsive to the
Mhm.
individual, and I guess there's just a point at which you say, okay, now it's time. Is that accurate?
Yeah, that's a really good question, and it's a fairly complex answer, but I'm going to try to simplify it. So there's one way that can work where it just adapts to the individual, meaning it's in real time recognizing how much work the person's able to do and what they're providing, and it just recognizes that and backs off its amount of assistance in real time. So it constantly is adapting to the individual. On the other hand, we can also manually turn it down. So the therapist can say, okay, I'm going to reduce its assistance and just by a button push, basically, to force the individual in the device to somewhat do more, if that makes sense. We can
Hmm.
also turn off the power basically altogether as the person starts getting better. And so you have the external structure, but you just don't have any support really of the motors helping to advance the limb.
Hmm. So our last speakers were talking about the brain believes what it can do, right? Which is a fundamental principle of neuroplasticity. How much of a role is that playing in this transition that these patients go through from your experience?
I mean, absolutely. I mean, it's that sense of confidence and that awareness and recognition is key. So once the brain starts recognizing and believing that it has the ability, then you're going to see that arc of
Mhm.
recovery really accelerate.
So, and let's talk about dopamine there, right? So, the excitement of that process. And so, that emotional impact causes this release of dopamine, which is actually training the brain to learn faster. So, from an acceleration standpoint, can you talk to us about that? So, with the emotional piece and how quickly that moves us quicker down the path of recovery.
Yeah, the dopamine receptors are just it's real. It's true. And that whole theory of functional recovery is is researched and validated. So I think it is important to recognize how your body's functionally recovering and understanding those, even if it's those small incremental gains, that you're moving in the correct direction.
Yeah, you're moving down the path.
Yeah.
Yeah, so I think we know the answer to this, but I've got a couple of questions, so I do want to respond to that. And then also, let me just remind individuals, please do, let's take advantage of Michael's expertise. Drop your questions down into the Q&A box on the bottom of the screen, and we will do our best to get to the majority of those questions. Um, so there are a couple of questions in here about the dependence on the system, right? Is there
Mm,
learned dependence on that? And so can you address that?
sure. So this is designed to be a rehab tool. So this particular exoskeleton is designed to have a place in your recovery during the rehab process, whether that's going to be an inpatient or outpatient rehab. So the way that it's utilized is more as an addition to your rehab but not as not a it's not replacing any sort of functional uh, brace or support that you would ultimately take home. So the way that I often think about it is use this as the rehab in for that really intensity of therapy during that session so that you can then again walk out of it and then replicate what you just learned and what you just did during that rehab session so that it isn't some learned dependence.
Yeah. And are these devices used primarily in early stage post-acute care when that movement is so minimal, or where in that process are you primarily targeting the application?
Yeah, the sweet spot I would say is that early mobilization because especially for those individuals who have very little or no function or the ability to even stand, this is providing all that support and giving those people the longer opportunity to stand and again just even walk where they otherwise might not be able to. But the opportunity here doesn't just stay there because it does grow and it just evolve with the person's arc of recovery, meaning that we can continue to change the way that settings are supporting the individual so that they can continue their own arc of recovery and journey. And so, but we really do focus early and then see how the person can grow out of it.
Okay, that makes sense based on the device. So, got a couple of questions now about how do they gain access to this? I know we talked about in sort of neuro rehabilitation sites. How, if
Mhm.
you're a patient and you think this could help you or a loved one, where do you go to get access?
A good question. So we are fortunately in quite a I think over 300 centers across the United States. And if you go to exobionics.com, our website, we have a Find a Center um, tab on the website where you can type in your address and you can find where one of our devices are located so that you could locate that rehab center facility that you might have access to access this technology.
Perfect. Okay. And I see they've thrown your email
Mhm.
back up here. So if people want to reach out to you directly, then they can do that. What are there other types? So this is primarily for mobility. We saw the Exo NR for walking. Are there any other types of mobility issues that are addressed by your company?
Yes. So we this we have a pre-gait suite, such a way they call it, so that we can teach somebody their midline awareness. It also has the opportunity that we can do something where you can split your legs into a split stance and you can do some weight shift and balance training. And then there's also an opportunity where you can do some controlled squats so that there's some strengthening in what we call pre-gait activities within this system. So those are some other features that are embedded into the exoskeleton.
Okay. And is insurance typically covering this, or are patients looking to or needing to do this out of pocket?
So insurance will cover this just as a typical therapy session. So basically, when a clinician is using these technologies for their treatment, it's just integrated into their typical session and then billed through their insurance as their PT session. So nothing is specific as an out-of-pocket expense to use these types of exoskeletons.
Ah, okay, got it. So, these suits are basically wearable computers, right?
Mhm.
You're collecting a lot of data, I'm sure. How are you using that data to customize the recovery plans and then to develop new technology?
Yeah, so that's an excellent question and something that's so relevant right now because of course data is key to everything. And as we know that AI is moving in very quickly and AI is fueled by data. Luckily, the EXO product actually captures a significant amount of data throughout every single session. And we have millions of sessions that we have recorded that we're starting to see, okay, I wonder how we can take this information and create an AI model so that we could potentially help create a better pathway of how these devices interact with the person. Now, that's definitely a forward-looking statement because it all is so new, but I have such a the way that my mind goes and how it's integrating AI into these types of devices, not only for the device that's used for rehab, but there is also a device that's designed for home use. And I think that when you're thinking about home and community use, that AI system, when it's looking at like the environment and the sidewalks, and if you think of autonomous vehicles, maybe one day there's going to be an autonomous robot that's going to help people navigate that otherwise couldn't walk or navigate the community in their home environment.
Yeah. That yeah, the future for this seems so bright. So what does the technology in the next 10 years look like? Where are we going to go from here?
Yeah, that's I think number one, I think it's going to be a lot more sleek because it's going to be a lot lower profile because I think it's going to even continue to further replicate all of the human movements because we have a
Hmm.
very complex system. Not only our legs and our walking, but the rest of our body. Because I think what Exobionics is focusing on, especially with this particular device, is basically waist down. But
Hmm.
but there are robots out there now for the hand and the arm, and I can just see in the future how all of these are going to integrate and they're just going to seamlessly start attaching. And then people are probably going to have some brain computer interface as well, where they're just going to, if they think about it, the robot's going to start moving it as they want their arm or their leg to move simply by thought. And currently it's more, it doesn't work in that direction, but I think that brain computer interface is definitely somewhere down the road.
Are you working on that now? Is that something your company's already started to integrate?
There's some researchers that are looking at this because the systems are very complex to go from top down and bottom up.
Hmm.
So there are some research that's being done with that. Yes.
Yeah. Okay. Yeah. So how are patients, how are you working with patients to develop that technology? And are you working with the rehab facilities that are using that and current patients to do that? Or are you mostly in a lab for that development?
Yeah. Right now, that's mostly in lab development because it's it it takes a lot of research umbrellas to accept some of these types of different research approaches because it is sometimes invasive, honestly, because of how you have to find and access the signals. So right now, a lot of it is done in, like I said, quite complex labs because we're looking at the different efferent and afferent nervous systems. And so how
Mhm.
we're getting sensory up and down and the sensory from the muscle, from the skin, but also then from the brain back to the muscle. And so when you're looking at those two different directions, it takes quite a bit of work and a lot of, it's not quite ready to be uh, in the clinic at this point.
Yeah, I can see that. We've got a question here also about the weight of that machine. Can you talk
Mhm.
to that a little bit and what you're
Yeah,
doing maybe
sure.
going forward to minimize that, the
Yeah,
weight?
so the weight of this device that I showed is 50 pounds. It actually it bears its weight through itself. So the user who's inside the device doesn't necessarily feel the weight of the robot due
Mm-hmm.
to the design.
Mm.
But to speak on the thoughts of moving in the future and some of the reduction of that. So really the weight is by design choice because we have these devices in rehab facilities and designed to be rapidly adjustable. And so it fits a huge amount of people, right? So it's not just a one size fits all, and we want it to be durable. So we made some very specific choices to have durable products and adjustable components, which adds to the weight. But my thought is, and in the future, when we are able to have sleeker batteries and smaller motors and more strong but lighter metals that we can use, it'll all just become more refined and sleeker as all technologies do as they advance.
Yeah, and that makes complete sense. And what type of metal is included in this and the material?
There's a lot of different types, honestly, some from steel to titanium, but
Okay.
so from like a very but some of like the in aluminum because aluminum is very strong and quite light. But there's a lot of different components, and the engineers probably have a much more thorough answer than me. but but we have a lot of different materials involved in the build.
The there's a couple of questions here around safety too. So
Mhm.
I think what safety has a couple different components, right? There's the psychological safety that the
Mhm.
machine gives to a patient who is trying to relearn their mobility. But then does this kind of remove the fear of falling? One, so that's that piece of the safety, and then the other side of the coin, which is this equipment going to damage me? So you want to talk a little bit about the emotional safety it provides, and then
Sure,
also the concern over having a machine control your movement.
sure. Let's start with emotional. So I would say that trust in these types of technologies is first and foremost. So when somebody, not always does somebody automatically put on a robot and just immediately trust it. Honestly, more often than not, people are hesitant to understand exactly what's happening. So getting them to understand the why and the justification of what we're doing is first. So we want them to have that confidence and trust that this is going to support them. Second, we always have a physical therapist or a trained clinician with them who understands how the device functions and can quickly educate them how they interact with the robot. Because that human robot interaction is very key to understanding how this works. So that's a really insightful question that person asked to say like, okay, what's the impact here of safety? Then you think of just general safety of falling and risk of that, the device doesn't self-balance. There are some exoskeleton robots out there on the market that do. And so if somebody is very fearful, there is a pathway for that. But this one is actually designed that the person is more of a dynamic engagement within the system. So manage their own balance and weight shift with the guidance of the physical therapist. So is it possible to fall? Yes. But I also say every single person that's ever walked this earth has fallen at some point, if you think about when you learn how to walk because of gravity. But it rarely happens just because it's very contained within the system, and the person is learning how to that. We ultimately want them to understand that balance and that functional walking opportunity that this device provides them.
Got it. Okay. Yeah.
Mhm.
Thank you. That was very helpful. And exploring both sides of those, the both sides of the coin for safety. So I know our conversation today is really focused on stroke, and that's what we've asked you to come to the table with. But FDA has cleared EXO for multiple conditions. So do you want to talk a little bit more about the application outside of stroke for motor learning?
Sure. So the FDA has cleared XONR for spinal cord injury, acquired brain injury, multiple sclerosis, and stroke. So when we think of the other three outside of stroke, for spinal cord injury, we have this. The way I look at it is not always do those folks have recovery, because if they have what is considered a motor complete injury, they may not regain motor function below the level of their injury to their spine. And so we do definitely have a place there. And we actually also have a pathway where they can take a personal device into the home. And that would become more of that, somewhat of the conversation of that dependent. It was a different means of mobility is the way I think about it, from a wheelchair and more of a standing and walking opportunity. For those individuals with acquired brain injury and multiple sclerosis, we have found great success, similar to the neuroplasticity of the brain, regardless of an AMS population, of where those plaques might be and what's impacted in their central nervous system. And for acquired brain injury or traumatic brain injury, I often equate that almost directly like somebody who had a stroke, where those the neuroplasticity is happening, and we are looking to target those functional pathways of recovery, utilizing this technology in a very similar way.
Okay. Yeah, and that makes sense. Yeah. I didn't know about the multiple sclerosis application, so that's exciting
Hmm.
for that, because mobility does become an issue. So then that makes me wonder about the spasticity issue, right? And so
Yep.
because that's really a large piece of what's happening with multiple sclerosis, it's the spasticity and inability to control. Is there any long-term change in using the robotic system for that spasticity?
That's a great question. As a clinician, spasticity is one of the most challenging battles we face, because it can change every day. It can change even in the hour, because we don't exactly know how that upper motor neuron was affected and how the body's going to respond to it today. We have had anecdotal opportunities where people have found great recovery from their spasticity using these types of technologies, meaning they'll share with us that they'll use the device today in therapy, and then they'll sleep all night long because their spasticity was not affecting them through their sleep
Mm.
that evening. And so those types of anecdotal stories really resonate for individuals and for the clinicians, to show that recovery process potentially. Um, I it's probably unfair for me to say that anybody that would do this would automatically have that same result, because everybody's spasticity is different. And I think that is important to think about and consider when, if somebody's interested in potentially seeking this pathway. It's everybody does respond differently, and I think that's an important discussion talking point to make sure we have.
Yeah, Yeah, because the brain and central nervous system are different for every individual, right?
Hmm.
So it is a very, and I think that's probably why your technology is one of the leading ones out there because it is responsive to those individuals' own growth and patterns. So it changes along with that. Um, I had a question here about hypermobile Ehlers-Danlos syndrome after stroke. Does this support that in any way?
Yeah, the nice thing about the device is it does protect the person's body and joints.
Mhm.
So it puts you in a very anatomically correct position. And the way that the exoskeleton itself is designed is it doesn't allow or permit some of those hypermobile movement patterns. And so it could certainly, I haven't directly worked with somebody with that diagnosis, but knowing the etiology, I'm sure that it would be an opportunity.
Okay, great, great to know. I just want to remind the audience, please do drop your Q&A questions into the box below, and we'll make sure we get to it. So I have another question here about a patient who's had an experience, a very positive experience with
Hmm.
EXO, and they're saying that the PT only used it for a limited amount of time, and they felt like if they had used it for more time, they would have advanced even further.
Hmm.
How can you address this? And are there guidelines that you give the physical therapy for their use? I'm assuming their call on in many ways as to how it
Yeah,
gets applied.
it is. It honestly is. It's like, so uh, I don't feel it's appropriate for me necessarily to tell somebody else how to clinically apply or clinically practice. What I do and what my team does is that we go and teach the clinicians how to use this most effectively. And oftentimes, some of those limitations that it may have been not directly associated with the device use. It might have been sessions, and I was fortunate to listen to some of Jeanette at the end of her talk, the previous one, and she was describing how she creatively would use her time and then her colleague, this an occupational therapist, time to try to extend care and
Mhm.
recognize that we do have limitations within our insurance systems that we have to creatively navigate. And so I'm not sure that it's hard to predict whether additional sessions in the EXO would have helped greater recovery. Um, so,
Yeah, I think that's and um well, where my brain is going on this is the fact that it seems like it's a very um, expensive device for a physical therapy team to get, right? And this was the situation with my daughter. It's like, well, we have access to this auditory processing, but we only save it for the very most difficult cases.
mm,
So I could see maybe where because the demand for this, I would imagine, is fairly high, but I would imagine the cost is also a factor when physical therapy organizations decide whether they're going to employ it, right? And so they're saving
mhm.
it for their very most difficult situations. What can you tell us about the cost for this and how how that's affecting where it gets placed and who gets access to it?
Yes. So the cost is essentially $175,000 for this system itself. And like I said, it does go into rehab facilities. So that is not the cost that's ever associated to the person who's using the device. And so, and these rehab centers that invest into different technologies are familiar with that price point on other technologies. And so when oftentimes, quite frankly, to be competitive in the market, they often will acquire different types of technologies so that they have supportive devices, not only for the people who are coming in, but also to attract some of the clinicians who want to work there.
Mhm.
And so, and then that also helps to pull people's choice to say, hey, I'm going to go to this facility because they do have access to different technologies and some of the leading potentially clinicians in your region. And so that cost is directly associated to the facility. And then, as I mentioned earlier, when the clinicians bill for their service, they just get to choose which modalities they use with their patients. And so whether they're using an exoskeleton or a tether-based body weight support harness system or something like that. But usually most facilities are going to look at some sort of or mobility tool that they have in their clinic.
Yeah, that makes sense. What's the do you have an average amount of time individuals are using this before we can see the progress that you showed in the video? I know that it's all independent, but or individual.
Sure.
Yeah, but are there some numbers there you could share with us to help set expectations?
Absolutely. So there's a lot of different research that's out there. There's one research article that states that there's recovery after a single session in exo, but that's not the typical or the norm. The standard that we usually discuss when we go in and we teach and are trained, we usually say use the device 2 to 3 times a week. Some of the early research was done and they were seeing people 5 days a week. And that's just not necessarily reality because when you think about your inpatient rehab stay, the clinicians have a list of items that they need to make sure that they're addressing to make sure someone can go home safely. Then we all know that therapy stays are shortening in the US right now. So if you have a stroke, the number of days you have for therapy might be 20 days or less, And so when we are looking to help our teams that are acquiring this technology, we're teaching them how to use it. We usually say, look at this as 2-3 days a week of your interventions. And so it's like almost like every other day that you're using the device. Now, different clinicians decide to use things differently. So oftentimes when somebody has a very low functioning person or they're not able to mobilize this individual otherwise, they may use it every single day because that's their only way to get them up out of bed and moving. As they get better, they may decide, okay, now I'm going to dial back the amount of use of the exo so that they can start helping them to progress out of the device and towards their home discharge.
Okay, thank you. I want to go back to the spinal cord injury for just a minute because, there's the Shepherd Center, for example, has just developed a venture capital organization and they're rolling all of their profits from that back into the organization to cure paralysis. And I know that they have been working with exoskeletons as part of their research and effort.
Yep.
What do you think is the future for your team in application for spinal cord injury? And do you see a path to use this to cure spinal cord injury in some way, shape, or form?
I had a very long answer to this, and I'm going to try to condense it. So, yes, I do believe that there is a pathway. And we are all focused on supporting a pathway to curing paralysis. Currently, I believe that one of the more recent pathways is a term called neuromodulation. You may or may not have heard of that, and others on the call may or may not have heard of that.
Yeah, but why don't you take just a minute and explain neuromodulation, though,
sure.
and call that out? I think that's helpful.
Sure. So neuromodulation is done in one of two ways. You can either do it with what's called an epidural catheter, which is something that's actually it's indwelling, it's surgically placed on top of your spinal cord. Or you can do what's called transcutaneous spinal stimulation, where you put electrodes on the skin and it puts a pathway of electrical current that basically goes through your spinal cord, but it's not invasive.
Okay. One's outside, one's inside.
Correct. And so what that is doing then is exciting the spinal cord and seeing if it can reconnect any of those neurons. Where I get motivated with this is the coupled modality, the opportunity to put them together. So you put neuromodulation and an exoskeleton. So if you think about that, so if somebody doesn't necessarily have function to their legs, but then you stimulate their spinal cord in such a way, and can you replicate, you're giving them the functional movement of walking with the electrical stimulation of the neuromodulation. So that coupled modality is key. And then my other talking point on this is cure a paralysis. So let's say that we get to the day where there is a cure to paralysis. So I always say there's still going to be trauma. People will still unfortunately get hurt in some because of just human nature. And when they're going through that recovery phase, I still think there's going to be an opportunity to teach them how to walk in an exoskeleton. Like, okay, we're going to fix the spinal cord. But while you're healing, we're going to remind you how to walk, and then bring back in the exoskeleton technology. So I see a relevance to the industry for many different facets.
Well, that's pretty exciting. And
Mhm.
what stood out to me too was this layering, and that's a big piece of what we're learning about in neuroplasticity is you're layering maybe traditional therapies with all of the new technology that's out there, or combining these new innovative technologies to
Mhm.
really advance well, and accelerate. I would say accelerate really is the key word there. So moving faster and farther with layering these. Are there any other technologies that you're layering with for the exoskeleton?
Yep. So a couple studies that we're working on are brain computer interfaces.
Mm-hmm.
So that when we're looking to see that communication, and let me think, that with neuromodulation are the primary things we're working on right
Okay.
now.
Okay.
Mhm.
Well, thank you for that. I want to take just a few minutes here. We've got a few more questions, but before we go to those, I want to ask the people in our audience, please, to respond to the poll that you'll get here in just a few minutes. Do let us know what you liked about our conversation today, how you found it valuable and can apply it. And please let us know if there's anything else in here that you would like for us to add into the conversation. We use this information to decide what other interviews we have, what other information you'd like to see, what kind of training programs you'd like to see from NPA, and to help guide where we can help build the ecosystem overall for neuroplasticity into our current healthcare practice that you receive. So if you do have any other questions for Michael, please drop them in the Q&A session or Q&A box down at the bottom. Michael, I want to thank you so much for joining us today and answering all of these questions. I guess I will ask one parting question for you, kind of back to this AI and futuristic look that we have here. Um, So everybody feels as though AI is going to take over all of our jobs. That's a common theme. People are asking and wondering what's going to happen. And so what role do you see these devices and the integration with other technologies playing for physical therapists as they move forward in their role, right? As their profession matures?
It's a great question. The way that I always position this technology today is that this does not replace the physical therapist. This enhances what we're able to do, and maybe reduces the amount of hands and body parts that we need to use to support the person. Forward looking with AI specifically, again, I only think this is going to help enhance what we can do to help support the individual, because I can see more prescriptive, not necessarily prescriptive, but an opportunity to allow people to advance their patient quicker, faster, and with better movement patterning
Mm-hmm.
specific to whatever they're bringing to the table, whatever their impact is from their acquired brain injury or their stroke or their MS or whatever it might be. If we can more quickly help to reduce any compensatory strategies and focus that brain to recover in the more perfect patterning and get that function faster with the right amount of intensity. I think that we're going to be helping people advance more quickly with the hope of greater recovery.
Okay, great. Thank you. Michael, I want to thank you for joining us today. I appreciate you. We had some great questions for you, and I want to encourage people to reach out. Do go to the website to find where you may access the device, which neuro rehab facilities are available in your area, or if you have to travel to find one, if you feel like it's something that could work. And I guess actually one more question for you, Michael,
Sure.
though I did forget to ask this one. I think it's valuable. Is if you're in a rehab facility, what would you encourage the care team there, or the caregiver, what would you encourage the caregiver to say to the care team to help ensure that you get access to this device in your rehab? Is there a way that you can help accelerate access to that through your conversations with your physicians?
Yes, I think the first is just ask. Make sure that you ask that if you know that the technology is available, ask if there are appropriate candidates. Because and then if there's justification that there's an outlier, that there's a contraindication, that I think that would make you'd accept that answer. But if otherwise it's fear, or the clinician doesn't quite trust the robot, just like I was talking about, that trust
Mm-hmm.
component, then maybe seek a different opportunity if there's any other clinicians that might be able to support them. Because oftentimes, not always does the entire clinical team at the facility know how to use all the different technologies. And so if you do go to the facility, you know that they have the technology available, make sure that that clinician, that your loved one has the opportunity to experience the technology if they're appropriate candidates.
Okay,
Mhm.
good, great. Okay, Michael, thank you so much.
Jerry, thank you very much. It was a pleasure. I really appreciate the opportunity.
Same here. We've learned a lot.
Okay,
Bye-bye.
great. All right, see you.